All right. My name is David Rodriguez, and I'm doing my project on web server security. And first I'll go into some reasons why that's a lot more important nowadays. Initially, web servers were just HTML code that was being presented. It wasn't dynamic. At the very most, it just wrote to tables, it appended files, that sort of stuff. So it wasn't really difficult to secure because it was just static pages. There were no ports into any sensitive data that the organization depends on. It was just basically presenting stuff. Didn't change often. In the 1990s, at the end, half of the 1990s, content management systems emerged. And it was significant because it allowed IT professionals to host web servers, and content was separated by the information providers. So people would provide information, IT guys would host the website. It reduced the amount of coding, if not eliminated in many ways. It gave the users a GUI to add information, provided ownership to different parts of the website. But the bad thing about CMSs are a potential security risk. They're database driven. Every bit of information in a content management system is stored in some ways on a database. And that's good and bad. It gave you easy places to store data, easy ways to retrieve data, but it also opened up a whole new way to store information, and it gave us an easy interface to access it. So they're really good for dynamic information. There's a large third-party developer group for almost all content management system platforms. So there's a lot of people involved now as far as how the web server works. So that opens up a lot of vulnerabilities. And since these are typically predominantly open source content management systems, they're well known. You can go download the code, see how it works. So the vulnerabilities are known through the community. The protection comes from the community, but it's well known. There are vendor-specific content management systems, large ones, but they're not predominantly at this point on web servers. They probably host. It's kind of a guesstimate, but I'm going to say 8% of web servers have a vendor-specific content management system. Open source content management systems are used predominantly in the market. Okay, so why we talked a little bit about this, but why web servers are so vulnerable? They're out of the box, generally more insecure than any other kind of platform. Somewhat because of like I mentioned before, the dynamic environment. They're updated often. There's developers writing programs for them. So there's a lot of reasons for its insecurity, but it's definitely the most insecure platform that's just straight out of the box. It's available for hacking all the time. You can't take the web server down. Everybody needs to see it. It's a good gateway into more sensitive areas now. Because of the introduction of content management systems, organizational sensitive data is tied oftentimes directly into the web page. A lot of IT people now don't realize the security issues involved, and I would say more times than not, the web server can access organizational sensitive information directly, right through the database. so they don't have stores. So anyway, it's another way. It's another reason why they're insecure. They almost all content management systems have either a database residing on the same server as the application server, as the database. I mean the web server, or there's another server, database server that's attached to it directly that has a store of all the information, which is generally bad. Like I mentioned before, web servers increase the customer functionality and can provide personally identifiable information. And there's a ton of other risks. There's unnameable amounts of risk in web servers. They're exploited constantly, down to probably seconds. They're attacked thousands of times a day. So they've really gone to the front lines. They're really a place of attack, an opportunity for attack for a lot of people. There's a lot of resources out in open source and journals that talk about very specific pieces of web servers, security risk, well-defined areas that are vulnerable, and people have addressed those vulnerabilities. But it's hard to find a really explicit guide to the security of a web server, down to details. NIST and Carnegie Mellon and a couple other entities have provided guidelines. And of course they don't get very specific in that information. And there's some reasons we'll go into that in a minute. But so it's really hard to find, unless you have experience. It's really hard to find information specifically about the holistic security of a web server. So, and that, like I mentioned before, if we publish that information, it's a security issue. We're given a guide to how to break into our servers. So that's not you don't typically find that information. Second, a lot of people make their living off of that expertise. So they don't like to give that information out, the different techniques or applications that they use to secure a web server. And third, like we mentioned, it changes all the time. Applications become obsolete, within months, weeks. The ways that the platforms that we put them on change all the time. So it's just a constant dynamic environment. Okay, so, and I'll introduce some of these. My paper goes into more detail on all these, but so there's some areas of protection, some general areas of protection. Of course, there's physical security. There's network level security, which such things like network isolation, intrusion detection systems on the network level, open ports, just a bunch of different network level prevention systems, network firewalls, physical isolation of network cabling, honeypots. I mentioned I have Snort as as an intrusion detection system at a network level security. There's also VMware security. Almost all platforms now are VMware or some hypervisor type of platform. So not only at the operating system level, network level, every other level, you also have to throw in a VMware level, and you have to do VMware security on the ESX servers themselves. So you have to defend the platform that your platforms are on. There's operating system security, which is kind of basic, and has been involved in even previous environments. You've always had to defend your operating system. I include things as encryption on those, patch update schedules, rootkit software, IP tables, firewalls on those, HT access, permissions, of course patches and upgrades. There's web server security, and the web server security would be things such as just permissions on the web server. It's diminishing its surface area to other areas besides port 80. And I go into details on all these. Database security, which is a huge issue. That's really what most people do. They'll attack your website to get to your database, or they'll attack your database directly. Databases are the goal for most of these attacks on web servers. And then there's content management security, so you have to protect that platform as well. So there's like 5 different layers that you have to protect all the time, and they're oftentimes the same as far as their basic security prevention from unauthorized people, limiting that surface area, keeping it up to date, those kind of things. And there's application security, so even the applications that reside on these platforms, the developers, for specific applications you may have that's being delivered through your web server, you got to make sure that the coding is correctly coded and vetted and tested. So there's a real world focus for my project, and it's a project that I was involved in where we basically did this. We provided HTML submission of sensitive information, and the project dealt with transferring that information to ultimately reside on an enterprise system. So, and they also needed ad hoc and schedule reports while the data was flowing through our system. That's why we didn't just go directly or dump straight to their system. We had to have information that people could generate in the meantime. And the system needs to be functional, flexible, secure, and resilient. So here's a rough overview of how we implemented it. So we have all internet traffic coming in. Everything's snorted. Snort is an intrusion detection system on the network layer, and all traffic goes through it, and you establish anomalies. It detects you of anomalies so you can see what's going on, basically. So everything goes through it, and then it goes out and communicates. It sends broadcast. So we talked about isolation. This all needs to be on a separate VLAN so that only broadcast traffic can be heard by these servers. That's another way to risk stuff. So anyway, traffic goes through Snort, and then it proceeds on to these servers. The data flow is one directional. So here's our web server up here, and so Snort, it goes through Snort, does its processing. All these are Ubuntu Linux platforms, and they all have signatures. They're all protected by OSSEC, which is an intrusion detection system on the host level. So they defend directly right at the host level. And the database servers have GreenSQL, which is a really cool thing. That it's a database firewall. It lets you profile databases prior to releasing them into production. So you tell it which commands you're going to allow. I only allow these 5,000 commands. Anything else, you just forget it, won't do anything. So, and they'll have htaccess on all their web directories, allowing just certain files or operations to occur. All the traffic's encrypted, and what we do is, so we get we have a honeypot as well. So all traffic goes to it to see if somebody's going to bite, and we monitor this traffic through Snort. And Splunk is I don't know if you're all familiar, but Splunk is a dashboard system. It'll let you create reports that are generated by logs, so you can create graphs easily, real-time monitoring of anomalies that occur in your environment. So anyway, So someone submits an HTML form on the web server. We've gone into all kinds of steps to protect it. It then dumps directly into this database. And we only keep that one subset. You can define it down to which, we only have 10 records on this database server at one time. So once we go over 10 records, then we dump it to this database and we truncate all the data on that database server. So if someone gets directly into the web server, which is the most often the avenue of attack, they'll find a database that has no information in it. And then if they continue, they'll get a little further. But so we dump this, and then we dump that into this database server. We clear it, and then the ad hoc reporting that we mentioned before comes from this database server. Lets us know more information about what's going on. And they also, all the reports also export so that we can build ad hoc reporting. This destination database server has a lot more information, but we wipe it every couple days. So there's a little bit of information here that truncates really quickly, a little bit more information that truncates on a slower period. And then eventually, on whatever schedules you define, it dumps to a file server, and then it truncates all that information. So the attacker would have to come directly into our system through some other avenue that we're hopefully monitoring, or they would go through the web server, which is a traditional way, and we've got multiple. So that area is locked down even more. And then if they're able to get in, they find various databases with nothing on them, or very little. And then this file, and this is what we were, in our provision for this project, is what we were really supposed to, the core of this. The core was to take HTML submissions and eventually dump them into a SQL file that's then uploaded into an enterprise system. Now, one of the bad things about this this situation, the agency that wanted us to do this project for them, like we mentioned, there's really sensitive data in this stuff, and we thought, well, why don't we go directly to the source and get the information? Why do we have to go through a web server to accumulate this? And you'll find this a lot of times in your careers. They didn't have enough people or enough resources to build that information in a way that we could use it. So we had, as part of this project, we had to take the responsibility on in protecting that information and accumulating it. This is actually kind of a bad way. If you ever have to do something like this, we tried to insist not to go this route, but in business, you really have to do what your customer wants. I mean, if we didn't do this, the project would have ended probably, and potentially no monies would have been exchanged. Their customers would probably have less functionality. So sometimes you have to do what you have to do, and you just got to make sure you take due diligence in protecting the stuff. And my project has a lot more detail on every one of these. There's endless amounts, and I've really just touched on some of the areas. There's a lot more. This is definitely a very difficult thing to secure. And I think most times, this is to give you a frame of reference to. Am I getting close? 1 minute. I would say these are estimates, but web server setups like these, this is way over the top in most environments. Most web server developers, IT managers don't really even go anywhere close to this link, which is kind of a shame. And in this, I went on too far in that, but also another thing, backing up in this, you got to back up all these different levels. So file level, you got to back up independently. You got to all have these independent in case you have a crash or just some level fails. Database level, VM level, SAN snapshots you can return really quickly to an environment. multiple access backups, so I need like 15 different copies. I can go back to either one of those, or 30 or 100 or whatever you require. And a remote sync location for an external disaster recovery. Log everything all the time at every level. Audit, maintain, review those constantly as a management process. And that's it. It's very difficult. It takes a lot of, nowadays, it really takes a lot of processes to protect web servers. And it's really important nowadays, too, because everything we do, as you know, is ran off web servers now.